Hi, welcome back to Mechanics and Control of Robotic Manipulator. I hope you have actually come in one stage where we have seen basically like the kinematics, then dynamics, then we have seen like one step ahead where the trajectory we have generated, that too like with robotic manipulator. This particular lecture, how we can actually like do the motion control. So in that connection, so we would be talking about motion control in detail. In specific, actually like we are going to talk about how to do you can say manipulator motion control. So in that case we would be talking about you can say what is motion control and what are the types, all those things. So in that case these two are actually like more specific. While going across, so we will see like what are the trends were there in the robotic manipulator control and what are the current concern which are actually like related to what you call robot motion control. So in that case, first of all, what is motion control? Motion control is a field of automation, but what it is doing, it is encompassing the systems or subsystem involved in moving parts of machine in a controlled manner. So for example, I assume that this is the you can say manipulator, which is actually like having, for example, two or serial manipulator which is fixed. So now I want to actually like move this manipulator in this manner. So in the sense what we are trying to do, so we are actually like making the system to follow the given profile, in the sense the moving parts of the system follow in a controlled manner. So that is what we are calling a motion control. So we'll see like in detail when it comes in real. So before that we'll just give, so motion control definitely you can say closed loop. Certain extent it can be a open loop, so where for example forward differential kinematics we have seen. So the opposite what we have seen is the inverse differential kinematics, which is controlling the manipulator. Similarly inverse dynamics also we have seen, it is controlling the manipulator, but what we said, it is a open loop or we call feed forward control. So that's why the motion control more often closed loop. However, certain extent, for example in the initial phase of the robotic system, so the systems all are actually like open loop control. So in the sense we purely rely on the model and we assume that the initial conditions are same, then we are actually trying to do it. So in that sense what we are trying to do, we are trying to monitor the actual path of the you can say end effector or the joint motion and correct that according to you can say the decide. So in that sense what we are trying to correct, we are trying to correct position and velocity, and accordingly we would be correcting the torque or force. That is what we are trying to give. Okay. So in that case the motion control contains several things. So one important thing is the motion profile, which we have already seen in the trajectory generation, so we call simply TG, and the target position, sometimes it is like a you call set point control. So then what we can see, like it is we have done up to this actually like trajectory generation. So now we are trying to see that how to control the motor or the actuator. So in the sense if you talk about the control system, the control system would be having a trajectory planner and the actuating system, so which would be required some kind of control you can say command, or probably you can say some kind of you can say relation between these two. So obviously if it is a open loop, the trajectory planner to actuator directly will go. If it is actually like closed loop, so you have a real robot, so the robot signal will be fed back to the you can say control unit, then that would be calculate the necessary you can say control signal or you call actuator signal to compensate the system in such a way that the error would be close to 0 or almost 0. Okay. So in that case first of all we will ask ourselves why we need actual like control system. So you know you can say like the robotic manipulator or robot system. So robot is not only a mechanical system, it involved or it fused what you call controller. So in that case simple optimal design or optimal mechanical design so is not sufficient, because once the architecture chosen, what we will try to do, the manipulator design we will do, which is nothing but the detail design of the manipulator, that definitely will do it, but that is not sufficient, because so the mechanical architecture is not the only one which is impact the performance. The controller also like impact the performance. So in that sense we have to actually like try to see how to do the motion control or generally control. So in that sense, there is one additional burden also come. This is very similar to all engineering application. So where the robotic manipulator mathematical model also very difficult to, you can say, find or found. So in other way around, the system is actually like working in real time. So the external impact we call external disturbances are actually like inevitable. In addition to the robotic system is actually like based on the, you can say, real time system. So real time system, definitely there would be uncertainties, because for example now I am saying that the actuator supposed to provide 10 Newton meter, but there may be a mechanical loss or probably some other losses, it may produce only 9 Newton meter. Similarly, the link length geometrically it says that 10 centimeter, but the manufacturing tolerance provide probably 10.1 or probably 9 point something. Similarly, you can say the joint also maybe end up with some kind of clearance and all. So in that sense, what one can see, it is actually first of all very difficult to find the exact dynamic model. Okay, several unavoidable reason. For example, the friction cannot be exactly you can say model it. So like that, several difficulties are there. In addition to that, what I said, the external disturbance and the parameter variations are inevitable. For example, the manipulator you initially designed as a you can say plain one. However, the manipulator is lifting some load which is unknown. So now what you can see that the parameter what you calculated based on the geometry would be differ, because the manipulators lift some payload, right? So in that sense, you can see like these are actually like inevitable. In that case, so like what we do with this kind of complex system, so you need to have an advanced controller. So normal conventional controller is not sufficient to do it. So in the sense, if you need a good performance, so the controller should be advanced. So however, in this particular lecture or in this particular course, we are trying to see how we can actually like obtain this advanced controller through the conventional or probably regular practice. So in that sense, so we would be asking ourselves, so why we need to actually like do several, you can say, control research. So there is actually like one important aspect comes. So here you can actually like see that the theoretical results are actually like several. However, what happened actually like the control is actually like in real time implementation is very difficult. So although we can actually like come up with a very modern controller, but when we do it in real time in practice, so the controller what we implement, in the sense the hardware may not be capable of doing that, or the hardware probably expensive one. So then we need to actually like compromise. So in that sense, you can see like there is a big gap between the real theory and the practice. So here we are trying to address few of them. So in that sense, first of all, we have to see how the trends were there in the control aspect of robotic system. You know, the robotic system started probably in early, you can say 60 and 70, it start getting some shape, and 80s it start matured. So in that sense, what mid 70 people have done, so we call this as a classical robotics, what they have done, so they have actually like consider whatever they build a manipulator or the robot, that robot is actually like exact dynamic model or exact model is known. In the sense, all are actually like free, or you can say free from the feedback, and what we can call it's actually like pre-planned motion. Everything is just like a mechanized. In other way around, we can say everything is dependent on the open loop control. So for example, I say that this is the ball, okay, and there is actually like a pit or some object is actually like in front. So I want actually like exactly this ball supposed to stay here. I assume that the ball is actually like going to pure roll, and I know the mass, and I calculate what the force required to stop from starting 0 to here. I make it a smooth profile. Then I can calculate this force. I continuously apply the force so that the system is stopped. Okay, I am not checking any feedback. So then what we can actually like see, this is actually like purely based on the model, right? If the model is actually like small, you can say perturbation is there, this may not work. But in earlier days, people are purely depend on this. If the system is actually like giving some kind of residue or probably error, they actually like recalculate this rather than actually like doing the feedback. So in that sense, the exact models are no feedback are actually like necessary. The exact model is necessary and no sensing is necessary for this particular system. Okay. So, exact model is required, okay, and no sensing is actually like necessary for the system. So, it was working good as long the system is actually like no wear and tear or probably no you can say complaints and all. However, so when there is a complaint, for example, I assume that this is a vertical robot, okay. So, it is actually like simple rotary manipulator, but the rotary manipulator is actually like in vertical. So, what happened over a period, this would be having a deflection, right. So, it is supposed to stay here, but due to this it may come here. So, in the sense what happened, this exact model may not work as such, right. So, then people actually like thought about it. So, then they said, why can't we use a reactive mode, in the sense we will deploy, you can say deploy the feedback, and we will do purely feedback based. So, in the sense what happens, so there is no model required, but it purely rely on the good sensing. If purely you can say rely on the good sensing, so then there is a problem. For example, you have a serial manipulator, okay. So, I am assuming that it is actually like 3R serial manipulator. If this is having a small error, which I call delta theta error, so this delta theta would be actually like propagate when it goes one another end. So, at the end effector would be completely drifted, you can say certain extent. So, in that sense you can see like the reactive paradigm worked in the actuator level very good, but the system level it was not really, you can say, beneficial. So, then the mid 80, which was actually like so popular, even that time the 3-term control which we call PID control were very popular. These all actually like good, you can say, reputation happened those days. However, later on the robotic community people rely on that, okay, this is purely depend on the feedback. So, in that sense the motion based control is not really good, you can say, performance over a period, or it is not giving the exact error compensation. So, then people thought about why can't we combine these two. So, where you can say system level, for example, I talk about the manipulator level. So, here we go with the model base, okay. So, and the actuator level I will actually like go with what you call reactive paradigm. So, in the sense you would be doing two level, so low and system level. So, low level I call actuator, okay. So, system level is actually like higher level. The system level would be based on the model, okay. This was actually like based on the feedback, okay. So, this was actually like working very good. So, that is what even now people are working in most of the manipulator community. So, in the sense it is actually like model based at the higher level and reactive at the lower level. In the sense actuator level it would be a motion based control, and the system level it is a model based control. So, these all actually like work very happily in the robot manipulator system, but the robotic manipulator come in autonomous mode, and people actually like try to put it in probably unknown you can say environment. For example, the picking object characteristic may not be knowing. For example, initially the manipulator all come with for a rigid body operation, or probably the body characteristics is purely known before in end. But now, for example, warehouse automation, where the several objects come in a rack or probably in a conveyor, and it need to put it in proper, you can say rack of the container. So, then it is actually like very tricky, because the system supposed to work, okay, and where the object is located, these also need to be work it out. So, then people thought about this unstructured and you can say planned activity. So, they depend on something called the probability, and in you can say mid you call 2000 onwards, the computer have actually like come up with very bigger sense. So, then they thought the probabilistic robotics would be one additional benefit. So, then mid 90 itself people try to attempt this. So, where they said that seamlessly integrating you call model and as well as limited sensing. So, based on that we can actually like make very good robotic manipulator control. So, these all actually like required additional computational you can say complexity. However, this was working for autonomous mode or probably unknown environment where we need to deploy this kind of manipulator. People tried a probabilistic robot. Mainly the probabilistic robotics have come for the mobile robot community. However, this was even used for the what you call robotic manipulator, where some certain extent the autonomous or intelligent operation required. Even in that case, in the modern days, so we know like the neural network have actually like come up very drastic manner into all the field. So the same was attempted even in 90s or probably 2000. However, that time the computational capabilities were very limited. If you are deploying the neural network, the training is required and you need to have a database which is supposed to be very heavy. In the modern days, the data driven models have come, which is regression based or probably learning based. So which was actually like changed the entire robotic community, including manipulator, which brought the learning based control. So the learning based control, either it's a reinforcement learning or deep learning. However, this is actually like purely depend on what you call data driven model. So this is what actually like one deep you can say insight. So this is mainly depend on if you are thinking about autonomous or you are thinking about some kind of intelligent manipulation, then definitely we can go with this. However, the conventional side you can still limit with what you call the hybrid, or even certain extent if the you can say manipulator is working very slow in speed and the structure is certain extent is well described, then we can go with still reactive paradigm. For example, even you take in the modern days, even you order it probably KUKA or FANUC, so the robot would be having a PID control or PD control. Okay, so why it is so, you should actually like know. In that case, we will actually like see what is the classification of what you call motion control. So in that sense, the robot motion control consists of several you can say task inbuilt. But before doing that, you should actually like familiarize the environment or familiarize about the task. So in that sense, so you should know what you want to do it with the manipulator and what is your system. Then you can actually like make the control specification what you want to do it. In the sense, you can come up with the objective. So in the sense, if you think about a control design, first you have to actually like understand the model. So in the sense, understand the physical system, and then you can come up with a proper model. Then you can actually like define your exact need. So what would be the exact need? So one important thing is, so your closed loop system supposed to be stable. Then your error should be within the you can say design limit. So in addition to that, you may end up with some kind of optimization, because your control input may be required to be as minimum as possible. You want to do it, or you want to make it the fastness to the system. So in the sense, optimality will come. So in the sense, if you think about the control objective, one important thing is actually like the stability. The stability and regulation, you can actually like bring it very close to that. So this is actually like set point, and this is actually like the you can say the desired input is actually like time varying. But most probably we will be trying to do this, the system supposed to be stable and you have to do the optimization. So here we will try to increase your efficiency of the system, or you can say decrease or minimize the resources. Okay. So in that case, so we are actually like bothering this. One important aspect I already said, the stability. So the open loop robotic system, that too like dynamic system, is unstable. For example, you take a simple mass which is actually like rotating, you assume that there is no friction. So how we can actually like modulate this? So F equal to ma, right? So in that sense, you can see that the second order system is actually like giving a unstable nature. So the similar way we can actually like see even the robotic manipulator is what you call, it is something like unstable. So in the sense, the first thing is your closed loop system should make it you can say stable, and you can actually like try to do the optimization and all. So in that sense, we have actually like seen what is motion control and what are the trends have come in the case of robotic manipulator control, and we have seen what are the basic idea for the control design in that. So there are 4 control objective. In that, one of the objective is very important, which is nothing but the stability, and Once you attain, then based on the given, you can say task, either it would be a regulatory task or the tracking task. The regulatory task people call it is something like a stabilization problem, okay, where the trajectory tracking people call servo problem, or probably they call you can say tracking problem, okay. So either way we can actually like say, even some people simply call motion control means tracking problem, okay. So the next lecture we will see what are the types in the motion control, and then we will actually like move to the you can say one basic idea of the you can say robot manipulator control, and we'll see some example in numerical case, okay. With that I am ending this. So the next class would be talking about types of motion control. See you then. Thank you.